Right here. What does this symbol mean? Perpendicular. What can I add to my picture if I know two segments are perpendicular? Nope. Right angle marking. Perpendicular means two segments or lines that intersect to form a right angle. So JY is perpendicular to YO. Yo. You add a right angle marking. What else do we know? NS is perpendicular to SO. So we have two right triangles on our hands. All right, what's next? What does this symbol mean? Congruent. Now what do I add to my picture? Now I can add tick marks, which tick marks, all they mean is that two segments are the same length. That's what tick marks mean. They're our way of communicating that two segments match. Ooh, O is the midpoint of YS. How do I show that on my picture? Where?
On both sides.
YO and OS. I'm going to use a double tick mark because a single one has been used up. A bad word? No. Oh, is it a bad word? Well, okay, so are the triangles congruent? So we have 5 different shortcuts to prove triangles guilty of being congruent. We have 5 of them. Let's name them. What are they? Okay, side, side, side. What was the first one we learned? Side, angle, side. What else? Angle, side, angle. Yes, angle, angle, side is one of them. And then we learned one of them on Monday. Very good. HL. From the song. I'll play the song again today. Anyways, so of these choices, we need to decide which one this is. Now, HL is special. HL can only be used in what type of triangle? Right triangles. We have some right triangles on our hands. Is this one hypotenuse leg? So here's how we check. Are there tick marks on the hypotenuse? Are there tick marks on one of the legs? Right here. Right here. So these two triangles are guilty of being congruent, and what's the evidence? HL. Are they congruent? Yes. If so, what are they congruent by? HL was the answer to the warm-up. Write it down. Okay. All right, let's practice on your whiteboard. I have no instructions. I literally just want you to know if these are guilty of being congruent or not, and write the theorem if they are. Go. Show me on your board. Very nice. Very nice. Look how easy this is. Don't look at other people's boards. Yep, yep. Try again. Very good. Very good. Make sure it came from your own brain, please. Very good. Switch your letters. Very good. Very good. Like I said, yes. This one is the sassy postulate. Very good. When you see tick marks, you write the letter S. When you see an R, you write the letter A. Literally, it will spell out your answer. These are guilty of being congruent, and the evidence is side, angle, side. Next one. Nope. Yes. Stop looking. I see you. You can't put both of those. Yes, yes, yes. Turtle. Is that your answer? No. You're getting me with the lowercase. Yes, I like that better. Yes. I will tell you what you need to put on the quiz tomorrow after everyone has shown me. Good. Good. Show me next time then. Okay, guys. We are getting a shortcut of angle, angle, angle. Does that shortcut work?
No.
So do you write it in the blank? It's false. You don't write angle, angle, angle. You write not congruent or not possible. These could be congruent, but it is not possible for me to prove them congruent because I don't have enough evidence. Sorry, they get off free. They're innocent until they come back with more evidence. So you don't write angle, angle, angle on your quiz tomorrow. That is not one of them. Oh, I'm ready. Sorry. Good, good. Try again. Try again. Very nice. Very nice. Good. Okay, I'll explain each of them, Alex, as we go. Try again, try again. Yeah, use your little helper. Those are your 5 options. Try again. All right. Trinity, what can I add to my picture? Where? Shared side. Very good. This is called the reflexive property. That segment is congruent to itself. When you look at your reflection is congruent to yourself. Reflexive property allows us to add tick marks. Now, last week, if we had looked at this, we would have gotten, oh, angle, side, side. We would put, not possible. But then on Monday, we learned, you know, there's an exception to almost every rule. And the exception to the rule is right triangles. Don't you get so mad when a teacher has a rule, but then they let certain people disobey it, but not you? Isn't that so frustrating? Well, we are letting right triangles disobey this rule. We're letting them get off free. This is HL because the hypotenuse has tick marks and the legs have tick marks. So you don't write NP, you write HL, and the only reason he got away with it was because boom, boom, right angles. That's the only reason he got away with it. He's the teacher's pet. Oh yeah, very nice. You got it. Perfect, perfect. Oh yeah, try again. Very good. Very good, very good. Try again. Very good, very good. Yeah. All right. Celeste, what can I add to my picture? I can add tick marks on the shared side because of the reflexive property of equality. Okay, does anybody see arcs? No. Do you see any arcs? Alex, do you see any arcs? Any arcs? Do you see any? So if you don't see arcs, don't write the letter A. I see all sides. I get an S for side, an S for side, an S for side. These are guilty. Evidence is side, side, side. No, good, good, good. Very nice, perfect, 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 perfect. Very nice. Try again, your order is just wrong. Good. That's 4 letters. Oh, you put a question mark after it. Good, good. It really does look like an S. Trinity, did you feel caught up already for missing Monday? Seems like you do. Seth, what can I add to my picture? Because of what theorem? Vertical angle theorem allows me to add angles there. Where I see an arc, I write the letter A. Where I see a tick mark, I write the letter S. It spells the answer out for us. Angle with a side in between, then another angle. Very good, guys. Can't get that song in my head. No. Oh, yes, yes, that's right. Sorry, yes. Yep. Yep, yep. Mm-hmm. Mm-hmm. Perfect, perfect. Ooh, y'all are going to ace that quiz tomorrow. Your order again, just the order. I'll go over it. Uh-huh, very nice. Did you get it right, Richard? Did everyone show me? Alex, did you show me something? When you see arcs, you put the letter A. When you see a tick mark, you put the letter S. Now, I have students ask me all the time, where do I start, Miss Stan? Which way do I go? And I keep telling you guys that you don't start anywhere, you don't go anywhere. You just ask yourself a yes or no question. Is there a tick mark between these arcs? It's a yes or no question. Do you see a tick mark? No. No. There is no tick mark there. So I'm not going to write angle, side, angle, because the side is not between the angles. So I'm going to write angle, angle, side, because that's the order that's on your little flip book. And that's how you know which way to go, because if you spell it like this, it's like spelling a word backwards on the quiz. Okay? Is that someone at the door? Try this one. Good morning. Oh, I bet she's really missing that. Thank you. Yay. You're not even smiling. Are you excited to get your badge back? I would be. Good. 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 Try again. Good. 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 Just because it's a right triangle doesn't mean it's always HL. Alex, what can I add to my picture? So, Alex, there's 2 times I can add things to my picture. Vertical angles and shared side. Which time is this? Do you see vertical angles or a shared side? Where? These are vertical angles, like this. Like back-to-back letter V's, V for vertical. So shared side, what's the shared side? Name it. Two triangles. Good, good, good. This is triangle number 1, this is triangle number 2. They're touching. They're not just touching at one point, they're touching at a whole segment. They are touching at BD. So now we take inventory of what we have. Side, then an angle, and then a side. No, wait a minute, there was no right angle marking there. Is that okay? Am I assuming? That's what? Straight line, 90 degrees. You only have 90 left. It has to also match. It has to be a right angle. So the answer to this one was the sassy postulate, side angle, side. Okay, ready for your favorite stuff? What additional information do you need to prove congruent by side, angle, side? No. Eagle look right there, first one. Oh, except those are not the right segments. Sorry. No one's gotten it right so far. Yes, Alex. I'm going to teach it, Alex. No, you said the wrong side. You named the wrong side. No, we already have that. I want to know what additional information we need. Thank you, Richard. Woo-hoo. You are not done. We do not give up that easily. That is not who we are.
We are one.
Very good, Trinity. I heard you. Very good, Seth. Alex, we are one. You're so right. Yeah.
Oh, hold on.
We already have a shared side. That is not additional. What additional information do we need for it to be side, angle, side? What are we missing? Where? Where do the tick marks need to go? They need to go on DA, and they need to go on BC. On our answer, do we write tick marks in our answer? No. We need to write what is geometrically appropriate to write. We can't. Tick marks are just like street talk. That's just how we talk in class. But the actual geometrically correct answer is DA needs to be congruent to BC.
Is that going to be on the test?
No.
Multiple choice, but yeah. But it's multiple choice. One of the choices won't say tick marks. They'll all be geometrically correct. You'll just need to pick which one is the right one. Side angle side again. Let's see. Oh, okay, that makes them easier when you complain about them. That just makes them easier. Look at your segments again. Awesome. Awesome. Ooh. Ooh. That's a cool way to put it. That's correct. The second one you don't need, but that first one's an awesome way to put it. No, those are the wrong sides. Okay, what do we already have? This is not additional. Good. Vertical angles, thank you. That is not additional, we have it. Now we need it to be side, angle, side. Side, angle, side. Do you see which side is missing tick marks that we need them on? So a correct way to put this would be BC is congruent to CE. We need tick marks here, and we need tick marks here. But Chris wrote something very cool. He wrote that we need C to be the midpoint of BE. And if C was the midpoint of BE, then BC would be congruent to CE by the definition of midpoint. Whoa, that's above and beyond. That's so fancy. Last one, last problem. Get my last eagle up. We keep asking you about side, angle, side. First one, very good. Still the wrong sides. Yes.
Oh, first one.
Second one. Yes. Yes, Trinity was first. We already have this side. We have it. Which one do we need? Very good. Very good. We need this one. Yep, to be congruent to this one. So all you do is name it. We need segment BA to be congruent to segment DA. Can you reverse the order? Absolutely. That's not a problem. Okay. Trying to decide. Okay. So today's lesson is called Justifying Statements. You're going to be given a true statement. That's what you have in front of you. You have a lot of true statements on this thing that says Justifying Statements. Our only job is to literally just explain why it's true. Have you ever argued your case to your parents? Like, you want to go somewhere that they said you can't go, or you want to stay out later, and you're like, well, here are the reasons why I should be able to do it. And you, like, argue your case. What do you want to say?
My parents never give me the chances when they know I'm about to say something that proves me right. They make me stop arguing.
Stop arguing. They make you stop. I'm sorry you're not able to give your whole argument, but that's what we're doing today. We have a true statement. It's true. We just need to back it up. We need to argue why it's true. Why are we mathematically allowed to say these things? So that's why you have that list of properties in front of you. Those are your like your answer choices. Those are your answer choices. So I'm going to say a true statement. If C is the midpoint of AD, then AC is congruent to CD. That's a true statement. All I want to know is what allows me to say that. What theorem or definition allows me to say that. So you can look at your sheet in the different choices. But, ooh, I do have a quick movie clip for you. Like, it's like 2 seconds long. Wait, yes. So, oh yeah, here it is. It's a 2-second movie.
Oh yeah, I saw that.
Come on.
Same.
Okay, 2-second movie clip coming right up. You can play. I mean, like literally, he's gonna say one word. That's all I wanted to see. I'll play it over and over.
Why not? One, two.
That's it.
What?
Listen again. One more time. The answer is in the question. So, on all of these, literally most of them, on 90% of them, the answer's in the question. Look at the question. What word do you see?
Midpoint.
So the answer is definition of? Oh, midpoint. Write it down. That's the correct answer to the problem. I have justified my statement. Let's look at the next one. If segment BE bisects segment AD, then AC is congruent to CD. Same kind of markings. All right, look at your choices. Look at your choices. Be careful. We can't just say definition of bisector. We need to be, because there's different types of bisectors. There's angle bisectors, and there's segment bisectors. Which one is it?
Segment.
Oh my goodness, the answer is in the question. Am I bisecting an angle or a segment? Segment. So this is definition of segment bisector. Let me teach you an abbreviation. A lowercase b with a circle around it, it means bisector, for real. I didn't make it up. All mathematicians use it. So you are allowed to use a lowercase b with a circle around it for bisector. You're allowed to shorten it. Okay, this one's a little bit trickier. If angle B and angle E are right angles, then they're congruent. Ooh, look at your choices. Ooh, what number is that, Rickon? Look at number 6. Is this one definition of right angles? No, you have to be careful. God bless you. This one's not definition of right angles. This is right angle congruence theorem. That one's a little bit trickier. But the answer's still in the question because I see the word right here and I see a congruent symbol. Right angle congruence. So the answer still is in the question even though it's not definition of right angle. Ooh, next one. We're going to have to use our picture for this one. Next one, if AB is parallel to DE, then angle A is congruent to angle D. You're going to have to pull some prior knowledge here. Those are a certain type of angles. Look at your choices. Not the word side. It's 10 through 14. It's one of those. Jonathan said it. You just put an extra word in there. Alternate interior angles. If it makes the letter Z like this, it's alternate interior angles. What do I write? What does it say on your page? I can write AIA, but what do I write after that? Theorem. Or TH would be fine. It's the alternate interior angles theorem. Y'all are complaining about this. I thought you were going to complain about this since we're writing so much. Okay, last one. Angle BCA is congruent to angle ECD. Why are we allowed to say those are congruent? This time the answer's not in the question. We've been saying it all unit. What is it, Trinity? The vertical angle theorem. Those, you have to look at the picture for that one. That is the VA theorem. Vertical angle VA. Vertical angle theorem. Cool. All right, try 6 through 8, or sorry, try 6 through 9, and I will call people to the board to write their answers. All right, so we're skipping 6 and 9. Alejandro, what do you think number 7 is? If BD is perpendicular to AC, then angle BDC is a right angle. The answer is in the question. Do you see one that talks about perpendicular on your choices? One of your choices on here? What is it? What does it say? Let's see if it matches. Definition of perpendicular lines. This one says, if they're perpendicular, then they're right angles, then they're 90 degrees. Does it match? What does this one say? If two lines are perpendicular, then they intersect at 90 degree angles. So it matches number 7 perfectly. So we're allowed to write it. Jonathan, what's number 8? Segment BD is congruent to itself. Shared side. That's not the answer. That's not the formal answer. What's the formal answer? I've been saying it today a few times. May or may not be the very first thing on your page. Did y'all hear me saying that today? Yeah. Reflexive property. When you add a tick mark to a shared side, you are really performing the reflexive property of equality. That's what you're using. That's your argument to why it's true. Well, not to the theorems, but yeah, there's a back to the page. So write on number 8, write reflexive property. And let's see if there's any I can get you to skip on the back. Let's see.
I say 10.
Circle number 12, number 13. You can skip 12 and 13 because those are not on your paper. Oops. So we're skipping these. You get to leave her and relax. Let's get through as many of these as we can. Number 10, Helen, what'd you get? Number 10, a segment is congruent to itself. Reflexive. Prop. Raekwon, number 11. Definition of perpendicular lines. Very good. Gio, what do you think about 14?
14 is definition of this.
Oh my goodness, you were so ready. Good. Definition of midpoint. Look at this, no homework. Savian, what do you think about number 15? Definition of segment bisector. Yes, sir. Seg, and then B with a circle around it. Chris, what do you think about 16? It's almost like 15, but there's a difference. We'll stop there. Look at 16. Look at the hypothesis. We're not bisecting a segment, we're bisecting an, there you go. So this one's definition of angle bisector. And y'all may pack up.
I don't know the last one.